forgot my microphone. And the intro music. Dum dee dum dee dum dee dum. Dum dee. Oh yeah, thank you. Thank you as I'm setting everything up. Cheer up me. Cheer up me. Oh dear. Shaders. SPIR-V. Programming Games Club. Welcome! I'm Blaze, the cantankerous old git, the person that hates humanity. Okay, that's me introduced. GPC, Games Programming Club, where you have a say in what we explore. Which brings me to the first thing of today. I have received from Karim Hamdallah 2 hours ago, why you do not make a small series about small projects like OpenGL Mesh Loader and Editor with I'mGUI or anything like that, rather than these useless long streams. Okay, my reply is, streams are interactive. Think about it. You may ask questions live and see the thought process behind the answer. Games programming is very, very wide subject. Read more. So, if there is a specific area you would like to see covered, then let me know, and have fun. I'm used to this kind of thing, especially with useless long streams, because I ramble. And that's the reason I do useless long streams. I can ramble information into a useless long stream which I would not put into a video. I am not a video creator. I will not edit my streams. You get real results from me. Okay. This is a real thing. It's an interactive game club. This is not going to school to learn how to do a specific thing. I will, however, interact with people to cover specific things. And as I journey through and people don't ask me questions or say, hey, I want this, I'm really interested in this piece of code I've been looking at. What does it do? How can it be made better? What's happening behind the code? What's happening on the CPU? That matters more than the programming language or any programming you can do. And as I've received that, if I now open up our research board, you can now see that I've got a viewer feedback heading with OpenGL Mesh Loader and Editor with I'mGUI noted on it, which means this is going to probably come up. I don't ignore people. I welcome this. And I am going to continue to do my useless streams. And thank you. That's perfectly okay. I understand that the person's first language wasn't English who wrote that, and there may have been a Google Translate thing in there. I don't think they meant to say useless. I think they meant to say rambling. That's perfectly fine by me. I can interpret it that way. That's my viewpoint. I'm happy with it. Good. Today, that's over with. So don't be offensive to that person in my comments. Anybody? Please? They weren't trying to be offensive when they wrote it. That's all I want to say. All right. Right, shaders, SPIR-V. Oh, I've got a viewer. Hello, viewer. Good to see you. Oh dear, I actually get viewers. Oh, we haven't done our upload for today. Let me just check back in on this. That's why I was here. Oh. We seem to have 2. Let's just have 1. That might be better. And we'll pop... This is yesterday's. Yesterday's long rambling stream. That says Programming Games Club. How? Our first model content. Something's wrong. Something's very wrong here. Right, cancel. I don't care. You're not doing things right. Don't do it. Right, our first model, Programming Games Club, is up on here from the 29th of March. Let's go back to here. We can pop over to Twitch from here. Oh look, I can see my stream. We can go to our content. We are broadcasting. So we have our first 3D model, 28th of March. Then we have a continued. Okay, so we need, I think I've just accidentally deleted the wrong thing. Never mind. I don't know what the heck it was doing. So we are going to re-upload you. Twitch doesn't always get it right. So we'll start exporting you. And we'll get it right. We'll make sure it gets it right. I am seeing that we are getting views. This channel was never meant to be popular. If you are one of the viewers who is coming up on here, welcome. Thank you for your interest. And if there are things that you want to interact with, you can join me on stream. I don't mind. Hello, another viewer popped up. Wow. Is word getting around that there's a nutter doing programming about games? Alright, this hasn't shown up yet. My phone dinglinged. So is that something or nothing? Your order, oh wait a minute, we've got my order coming through. This one that was supposed to come yesterday. Your order from Thingy Club has been shipped. View order, blah-de-blah-de-blah. Tap to load preview. It told me that this order was to be with me yesterday, and it isn't. Save this number. We'll add a new contact. Oh my god. Welcome to Let Somebody Hack My Phone.com. This message has a https www.thingyclub.com/loads of numbers thing that I can press, and a little button below, tap to load preview. This looks as innocent as can be, but at the same time, there's no way on this planet I would ever click on anything like that. I will, however, keep it for investigation later on. I think I will be downloading that to a computer, and we'll be having a closer look at this. It's not that I don't trust the sender of the message. It's just that they've sent that as a message to my phone over an open internet. Yeah. Okay, processing will begin shortly. So we've got you. That's this one, isn't it? From the 30th of March. Yeah, that's right. That matches up. So the 1st of April, it was yesterday. It was April Fool's Day. I thought that the mail that I received was an April Fool, and yes, it was. I realised that by the time stamp on the message being sent. It was sent at 10 o'clock on the 1st of April. 10 o'clock at night. And I received it at around about 8 o'clock in the morning. So it was sent after it was received. Clever stupidity. No, you're not going to be hacking me like that today. Start export. We'll pop this other one up. See if we can catch it at the beginning. So we are going to do the shaders. But not until I'm 100% sure that we do have this available to you on the Fraser Sharp channel on YouTube. Everything is being stored as we go. It looks like we might be doing a little mini-series soon on OpenGL, which is interesting. How to load a mesh, view it and change it using something like I'm GUI. I like that idea. I think that's a very good idea. Okay, we can now refresh. And the second processing should come up. Right, so you go to add to playlist. There we go. We should now have 2 blanks. And they should be here. Yeah, they are being processed. We'll leave it to it. How's about that? Shaders! Speaking of, are under the Vulkan tutorial. They are not under Qt, as it would seem that Google has beaten everybody to it. Google has released a shader compiler because shaders in Vulkan are compiled, whereas shaders in OpenGL are human readable text format. That's an interesting idea. So there is this thing here, a GLSLC shader thingy. This tells us all about it. The shader module's part of the Vulkan tutorial at vulkantutorial.com. Nice. Compiling the shaders. It's got everything there is to know about it here. Where everything is and where to get it from. glslc.exe by Google. That's what they're using. You do get a GLS lang validator with the SDK. So you can do this at runtime. It can compile at runtime using CMake or something. But we won't be doing that in this tutorial, so I'm not going to do it yet either. I'll follow the tutorial. I'm not stupid. Did I just state that? Maybe that was wrong. GLSLC. I know nothing about this. Reading through this stuff, it looks like it operates in the same way as GCC. And all we're looking at doing is executing a simple command under Linux or Windows to compile a shader. These are the commands here. So that's your Windows command, that's your Linux command. Very simple to use by the looks of it. I don't see a problem with that. Alright. I think this is where we're up to. So can we go back to Vulkan? Because that's what we're looking at currently. Let's get on with things. We were over here somewhere on this board, weren't we? We've gone through our buffers. We're doing our first model. we'd come all the way across the board. We'd come across to loading our model. We got some ticks. This is where we ended up at the end of last stream. Need new shaders. Compiled, because it's Vulkan. They realised that shaders don't need to remain uncompiled, so they are one step ahead of OpenGL yet again. Let's head over to a Linux box. I could do this on Windows. We are on a Saturday. Are we on a Saturday? Sometimes I like to change over to Windows on a Saturday. We are on a Saturday. We're going to be using third-party software by Google. Do I want that on my Windows machine? Do I hellas like? Here we go. So, I typed in on my Linux box, get rid of this mouse, that's Windows. Let's get a... This is a separate computer. Obviously, it's got a different mouse. GLSLC. GLSLC to LLC. No, I didn't want that. The application is not installed. It may be found in the following package. So, going to that package is here in Package Manager. I'm not being overly careful, I'm just saying that you should check things. GLSLC. GLSLC. Return. And it gives me that. Shader C. Okay, let's try that. Ah, we've got one of them. There we go, just click on it. It is indeed Google. And here is the code for Shader C compiler. It goes into all of the information. This is at https://github.com/Google/Shader C. That's where you can find the code for Shader C. It comes to down here, status, file organization, getting and building Shader C. Tells you how to do everything. Building and running Shader C using Docker. Why do people want to use Docker? Do they not have a dedicated machine? I have a dedicated machine for this kind of rubbish. We're on it. So I'm not going to need Docker. Bug tracking, test coverage. It has a test suite. Nice. Bindings. It does mention something about Python 3 for the test suite in this writings. If you start moving around. There is also... not here, there isn't. Yeah. Okay, got me thought back. There is also example stuff for the shaders. There's a whole GitHub full of examples for shaders. Literally a full GitHub full of shader information about this. Access to it, can't remember how I got to it, but I have seen it. Okay, we'll keep that open for a sec anyway, because we're going to install that, obviously. This is why you should program on Linux primarily, Windows secondarily. Because Linux, when you're doing your pass one code, when you want things to work, Linux can do this. You want that. Oh, SPIR-V tools. Shader C, yes please, we'll take the lot. Well, thank you very much for doing that. That's very kind of you. Right, so we now have it. Alright, I was using the wrong keyboard for replying to that thing, wasn't I? Yeah, okay. We now can run GLSLC. No. No input files. It's usually H, maybe? Yeah, it says it's H. Typical Linux usage. Tells you how to use it. There would probably be a man page as well, I would think. See if it mentions that. Okay, Vulkan 1.3 is SPIR-V 1.6. Of course, we all knew that. Alright. Is that needed? This will compile OpenGL as well. It doesn't just go for Vulkan. It looks like we have OpenGL 4.5. So if you were to use OpenGL 4.4, you'd probably be okay. That's good to know. So not only can we compile for Vulkan, we can compile for OpenGL. External to our program, this has got nothing to do with our program. So let's find ourselves some base code. As is, always use your examples. So Qt examples. We are looking for Vulkan. We are looking for shared. Under shared, I'm not sure I like it like this. That's better. Okay, bring this down because this is the top left-hand corner. We have a color.frag, a color.vert. We've got the SPIR-V ones that we were using. I think those are the two that we were using. We can check it. We're in Twitch, Rana. We are doing tools. We're developing a tool to convert files into binary. We'll convert models, 3D models, into a binary format which we can load directly into our program buffer, and it's already in the format of what we need for our shader. So the buffer doesn't need to be converted, fiddled with, or messed about with. We can stream models into, basically we'll be able to stream a model into our program on the fly. That's the idea. This is the build directory. We were using... We're not using the build directory. Really? What are we using? Vulkan rendering, CPP, yes, thank you. Shader, create shader. Open file. Control F. Next. Here we go. We've got a QString literal. We are picking it up from source resource shaders. Nice to know. So we're not doing it there. So we can come out of there, can't we? So go over to here, source, resource, shaders, and voila. We have these two here, in here. What we need to do now is take you two, because these are the human readable versions, and just copy and paste. There we go. We can close this and we can now open terminal. Here. Thank you. So we're now inside of this shaders area, inside our lovely developer tool. Let's just list out everything. There we go. We've got the fragment, the color fragment. I'm going to be lazy. I'm sorry about this, but I'm just going to put in code dot. I'm not being funny about this. It's just that in Linux, you have a big problem editing and messing around with things like Vim. You don't have to. You don't have to suffer that. There's no reason for that to exist these days. When you've got a program like VS Code, which can look at the shaders directory for you, why bother? The marketplace has extensions that can help with .vert files. Search marketplace. Shader language syntax highlighter. This is not GLSL. Who are you covering? Sugar. What language is this? Is this H? No. Dudes, what language are you in? As opposed to human readable syntax like GLSL, HLSL, yeah, I know that these exist, but what language are you in? What are we compiling from? GLSL is the shading language with C star. Okay, it looks like we are in GLSL. But we're not quite. I've noticed some differences in the format that they use for their shaders, which are not simple GLSL. But they're interesting. Yeah, it is. It's GLSL. Alright, we'll go with that then. Fair enough. So this is by who? Silverseek. Anybody in this list that we know? Or do we just take a random person who's made a random language thingy? So these have not been made by anybody, like a company or something to support their product. Well, what can I say? GLSL. I'm looking at names. I'm not looking necessarily at what they do. This is the one that it pointed us towards. It's a 5-star. People like it. Doesn't mean it's safe. Oh, we've got snippets here. Oh, wow. Cool. Don't want any thanks, but cool. Might be helpful for some people out there. Okay, I'm going to take it then. It's this one. This seems to be what people are using. I am not going to say please use this because I do not know of any security issues at this time for it. Okay, we do have a couple of changes to our source control. Okay. There we go. We've now got highlighting. Oh wow, that's good. It gives us some purple bits. Nice. This is what we are currently using. Is it? Okay, if that's what we're using, then our shaders are correct. Yeah, that'll do the triangle. Yeah. Okay, can't really read it from here, can I? No, that's coming through in binary. So we're using 450. Okay. There's nothing wrong with this shader. I thought that was a Vec 2. And they've got a Vec 4. Okay, so we've checked it. We don't need to check that anymore. What I can do... Other files. Shaders are here. Let's just pop you in here. I want the position, please. That's just data storage area. So there's a GL position. Okay, V color. There's main. And it just ignores everything. So main goes to the top. The beginning of the file. Position, there will be an end character. So there's a start character, there's an end character, and then there's data storage. Alright, and these are HGGGGs, which probably means something. That looks like a matrix, maybe. Got 2 H's. So G, G, H, G, H, G. These are reference markers for, that's your pointers for the memory locations. But yeah, it's looking that way. We've got an equals or greater than in, so we've got also here some kind of mathematical function going on. Okay. Doesn't look too bad. This is colour vert. I do investigate these things. Sorry about this. I've got a Vec 4 and a Vec 3. So it is using those. We could make sure and compile these. Let's try. So the first thing I will do is I will take a copy of this as a reference. So file. And we are going to call it reference. Underscore vert dot SPV. This is how a researcher approaches this, not a programmer. Done. Okay. So we now have a separate copy of that. It's here, reference. We will be... We need to open reference, don't we? So we need to close this one, because that's the one we're going to change. Got it wrong. Can we just get all of this rubbish off screen? Whatever you got open, just get off screen. File. Developer tools. Source. Resource. Shaders. I want that reference up, please. Does it look the same? Yes, it does. Yes, that's exactly the same file. Good, it's a copy of the file. The command that we are told to place in by our wonderful tutorial I've completely lost again. Don't want to load this. Here we go. Right, so I'm on Linux. We're going to use that name of file, object file name. I can do that. So I would need to just make sure I'm clicked into that window. It's, you won't be able to see what I'm typing, but I'll hopefully get it right. GLSLC. It's going to be shader vert. So that's going to be color.vert. Color.vert. We'll type in. We'll put a -o, which means to object file named whatever we put in next. And that's going to be color_vert.spv. color_vert.spv. Right, we can now check all of this. There we go. I can't use this mouse. There we go. That is the command. It's got ticks everywhere. Good. Before we set that command off, I will destroy color vert SPV here. Move to waste packet. There we go. So that we don't have it. There we go, it's back. What we need to do now is just pop over to our main window. We have a little doofree here, split side by side. In this window, the new vert that we've just done is here. Make sure it's the same. It is. Just run down the first line, you can see that it is. Or is it? It's changed. Oh, Google. Google, what have you done? Why have you left a message in my main? GL Google CPP style line directive, GL Google include directive, main. Thanks, Google. A programmer wouldn't have checked. It's the same file, but Google have injected their own code into your file. What that code does, no idea. And I'm not even going to look at it. Do you trust Google? I know the answer to that already. I don't need you to reply in chat for that one. Our data's still okay. Has it added extra data here? Well, it's all misaligned now, so it's hard to tell. Alright, 6, above the 6. Yeah, we're okay. Goes up to semicolons, which are end of line breaks. Don't think it's added a data set in. But it has put buff MVP. I see what it's done. So it's just named the places in assembler. This is assembler language. This is starting to look more like assembler. It's an object file. Can I disassemble that? Probably. Yeah. Main. Yeah. Okay. I think we're alright with this. I'm going to believe them at this point in time. I will not be attacking Google yet. These are the things you don't get to see. These are the things that if you go and learn about programming, they won't teach you. They won't teach you how to protect yourself, that's for certain. Right, so we know that we've got our shaders up to date, correct, and the shaders will work. I know that because that's the Vec4. And I know how that works. Now, if you don't know how that works, it's quite simple. This shader is going to run on your graphics card. And on your graphics card, it is going to expect you to send in a stream of data into these layout locations. These layout locations are pointers for input into the program. These are global variables, basically. in any other sense of the word. A uniform can be altered once per program being run. These locations and this data is being streamed in. So, yeah. So it's a difference between a variable and a constant. So these are constants and these are variables. So that's the difference between these two types. So you've got your constants there, which is our map4, which holds our model view projection matrix. And we've got this slot position color. That's your inputs. Those are your inputs. And we are going to output the color there. That's an interesting way of doing it. You don't need to do it that way, so I wonder why they did. There's your output. That's the variable we're outputting. There the variable is, it's equal to this. So it's a straight pass through of the colour to the vertex, from the vertex shader. They've used my notation. Oh, okay. And that's going to be sent off, and it'll make its way to the fragment shader, where there'll be an in statement, which is a copy of this. So there'll be a copy of this in the fragment shader saying in vec3 v. Wonder why they're using a vec3. It should be a vec4. Ah, bugger. Our colour's wrong. They're not using the alpha value. We have red, green, blue, alpha. It's missing a channel. Why haven't they put the alpha value in? So I thought they were right. They're not. So we are going back to code. Code dot opens this. We go to this, and that's wrong. That's a vec4. So that makes V color a vec4 because it has to follow on. And that is now fine. The problem is that now doesn't match in our fragment shader. Here. In our fragment shader, you can see it's coming in as a vec3. Well, we can't. We have to have a vec4. And we are sending out a vec4 as a frag color. You see they're adding the 1 here. The fourth component, the alpha. Okay, we can alter that. It's a straight pass-through. That's fine. We're saved. We're good. Okay. Fantastic. Edited. Don't need to do anything else. Oh, damn. Not sure. We might have to. We should keep this open then. No, it's the vertex I thought I made a mistake in. I didn't make a mistake. That's not very usual for me. I like this. I like that a lot. And I like the way they've used it. Remember, this is C. Basically. I can't keep you open because I'm about to use you. Okay, colour.vert will do you. And we'll also do frag. So just change you to frag. And we will call you a frag. Okay, we're up to date. We are now in vector 4 land. Now, due to the way this system works, I will do a clean. And that means I want to do a rebuild. Let's just pop you through, make sure I haven't made any messes. No, we're looking good at 4 seconds to compile. Good. Everything's working nice there. Swap chains are up. Resources are up. I'm not seeing any massive errors here. We've got all the Vulkan. We've got all of the data. I'm a bit worried about that one there. I told you that computers cannot hold certain numbers. There's the truth about that. That should be a 0. And yet look at what it's put as a value. That's computer generated, that value. Everything else looks okay except for one value, which is an absolute joke. Have we got enough data here to make what we wanted? We have. We now need to plug that data into our newly formed colour shader and vertex and fragment shader. I'll get it right eventually. Okay. We don't need this open. So that was an interesting ride through building shaders. In OpenGL, you have to write a program to do that. In Vulkan, you do it on the command line. Which means you can put that into a batch file, which is what the Vulkan tutorial was saying. You put it into a batch file. I'm not putting it into a batch file because I'm not interested in the shaders right now. I'm interested in the buffers now. We have buffers galore. All right. What I would like to do at this point is move one of the commands that we've got. Because I've realised something. We've been displaying to the screen the output of our loaded model. Our loaded model buffer, the one that we've created, we've loaded into a memory location. All the data for a model, a 3D model. And it's this game model here. Problem. Does it still exist at this point in the program? Or has that memory been reclaimed by the operating system? Why am I asking that question? Because we have a model loader. Is it just a H? No, we've got a CPP file with it in. And at the end of this model loader, there's a bracket, the most misunderstood thing in C++ and C. The bracket. Actually, it's the most misunderstood thing in most languages. When being taught about the languages, they call it scope. What they don't tell you is that that's a program. Yes, that bracket is a program that runs when it is encountered. That program takes all of the local variables within the scope, the two brackets involved, from here. Actually, we'll have this scope, shall we, please? From here to here, which is the scope of our function. And when that bracket is hit, every single local variable is destroyed. The memory should be freed up and returned to the operating system. That is a specification for C and C++. Oh yeah, we've still got that null pointer, haven't we? Thank you. I'd forgotten to take that back out. I took the line out so that I could see what would happen if we could crash the machine, and we could crash the machine, which was good. So we now know that this is running a program that's releasing our memory back to the operating system so the operating system can access it. That means the operating system may change our data even though we still know the memory address. Yeah, we've returned the memory address. The data's in memory at that point in time. But then we run this program that says, hey, operating system, it's all yours. Do what you want with that memory. That's called a memory leak. Well, that's what they call it. It's not actually a memory leak. It's just the way we're not supposed to do it. Okay, so don't do it this way. There's the truthful answer. Let's have a look at loaded assets. What happens with loaded assets? We make it here. That's in the wrong place. That's the first thing. I can't continue trying to develop this now knowing that that is a dangling pointer. So we need to move that. It doesn't belong to this model loader. This model loader is a utility function. And we want the model for use by our program. It is the whole point of our program is this model, and yet the memory we have assigned to it is in a utility program. That should raise all warning flags and say, yay, that's wrong. And it is wrong. But it works fine. Up to a point, which I'm not going to talk about. Right. So we know that's wrong. The first thing we have to do is remove the return value. That is our return value. That is a void. That's your first thing. You must do that instantly, because it is the return value that is messing everything up. So it now reads void blah de blah de blah de blah, but now we need a game model. Game model. And whatever we called it. Which now doesn't make too much sense, but hey ho. Click the little bulb and it'll pop it all in for us. This is now a redefinition. Member reference type, blah 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 blah, is not a pointer. Oh. That's interesting. So we can access it direct. I didn't realise that. Fantastic. So be it. We're no longer dealing with pointers. Bonus. Okay, return. Well, there's no return values. There's no memory leak anymore. When that was causing this to be a bit messy. Remember, it was saying there's a memory leak and everything, and things weren't doing too well. Well, all of that is now disappearing. That's a dot. We are accessing this directly. Now this is illegal in programming. This is called creating a side effect in functional programming and is to be avoided. And yet, it is correct. With no return value anymore. Not needed. Fine. Okay. So we take access to field results in dereference. Of a null pointed loaded from variable scene. Okay. Yeah, we still need that return in then. We just don't want a value. Okay, that'll return. That'll take that away. Good, thank you. See, we've got the alpha here. I could have just taken that out. And that's that. We now have our game model giving us the same result, I hope. Oh no, we don't pass it in. Whoops, bad string. Helps if we do. What are we passing it in as? A reference. Here it is. So let's go back to our model loader. So we need a new game model. Oh, this is easy to do then. Well, it really doesn't matter. We can just do that now. And just give them a reference to the model. Non-const L value referred to what? There's no constructor. There's something wrong here. Can we clean this, please? Thank you. Non-const L value reference to night game model cannot bind to a temporary of type game model star. What does that mean? It means we haven't given it a default initializer within game model. Game model itself cannot initialize itself. So we have to new it. We're forcing people to put a new statement here. That's a problem we can change. It isn't a problem. It's something we can change if we wish to. Take you off. Do we dereference this? I can't remember how this goes. Ah, yeah, we just dereference that. We can just send the pointer through then if we've done it that way. But I don't want to. How is this going to affect the workings of our program? Let's just check it through then. Okay, doesn't change anything. We still haven't got the output, but that's beside the point. I'm not really thinking about that. Oh look, we've got some more of these stupid numbers coming up. You see how it's different every time? This is how badly computers handle real numbers. Because those are real numbers. Computers can't handle real numbers is the answer. And this is why people fall through the floor. Yeah. Because the vertex is supposed to be there and it ain't. It's somewhere else. You'll find that two vertices don't match up precisely and therefore there's a gap in between them. And that's why you fall through the floor. That's the practical reasoning behind it. How far are we in now? 1 hour? Break. Come on. Look after myself today. I really am struggling at the moment in real life. So I need to look after myself. I was going to do the output, wasn't I? Before we break, let's finish off this part. The output is here. Ouch. So I don't want that there. I want this in our renderer. I need to know that our renderer receives our model. So we can just pop it at the base of the constructor, can't we? Here. It's called mmodel. We'll use mmodel. I want to know what's there. We've protected it from the operating system, messing up our data. That was the first thing that we had to do. Now we should get literally... I'm going to do a rebuild as well. And I also want to know, why are you open? Alright. Let's run. Should give us the same output. It does. Again, we're getting these spurious things. Fine. It's not in main anymore. That's the only thing that's wrong. This is now coming from here. Lovely. Done. Complete. I need a coffee. Sorry, but today's going to go a bit slower. How can it go any slower, they say? Well, I did just pile in to how to protect your pointers from the operating system and rush through all of that. I have covered this in length in previous streams, so I'm not going to go back over that unless people ask me to. So we've done all of that. We've done new shaders. We're on to review buffer setup. Okay. That was fast for me. I'll go put the kettle on. Oh, thank God for that. I needed that. Just need a little break. I was racing through that too fast. Hopefully I didn't make any mistakes. If I have made any mistakes, let me know. Don't mind. As you have already found out, I actually don't mind anymore. So let's go. Oh, we're into this stuff, aren't we? And it's a big, horrible mess. We could have left this vertex data up. We should have left that vertex data up. Blast. I've made a massive mistake. Oh, hell. Hell's bells. Oh, by the way, you don't need to pass the model through. We could have called the loading of the model here. Or load the model anywhere. Or pass the model into our rendering from any place in our code. This requires a new function, IE colon set model for rendering. No, that's a good name. And that would then be, and that. Never ever put code into your comments. He says writing code in his comments. This is not a note for you lot. This is a note for me. This is a private note. It is not to be published. This needs to be removed. So everything that's there please delete following in pass2 as it details code. Right. Left myself some instructions. This is pass 1, I can do what the hell I like. Notes taken. I am thinking of returning this now to our vertex data, not using our model. So we will need the original. We can close this. I think we're done. I'll keep you open for a sec. Interesting stuff in there. Let's go to GitHub and find out what we've got. Do we still have the original? No, we don't. We have the original in Rana. Vulkan Widgets has a copy of the original. Here. There we go. Where vertex data is alive. Good. Thank God for that. So we do have the original. It's here. Lovely. Let's alter ours. We should have on screen a triangle. We should. So, vertex data. Let's control find vertex data. Find next occurrence. And this is down here. At line 100. God, ours is going to be so different, but it's around line 100 somewhere. And it's under constant VK device size vertex allocation size. So we've got constant vertex allocation. This line here, 106. We found it. We've changed. Well, I have changed. Preemptively, without testing anything, I just preemptively changed this to see if it'd work. And of course it didn't. No qualms about that. I wasn't expecting it to. So let's get rid of this piece of garbage code. It's not the size of a float, it's the size of vertex data. Okay. So I'll pop you in there. Why does this not have a thing going over to the left on it? Where's the left and right going? And why isn't it there? Comma, uniform alignment. Okay. That's fine. Our code is good there. Alright, that was a first change. Let's go to the next one. We have the mem copy of the vertex data. into the address pointed to here, which is mapped to our GPU on line 131 plus 6, 137 area. Oh, I've got lots of notes here. I'm looking for a mem copy. Yeah, and we've got this same thing going on here, which I didn't look at properly. So it's mem copy, vertex data, to size of vertex data. Okay, that's redone, re-put back. And that's it. There you go. Our shader works. But the data's wrong. It isn't actually. It works. And that's because you have to know how shaders work. And we better go back to the shader for that. So it's wrong, isn't it? We've got 4 numbers for a position, 4 numbers for a colour, and yet here we haven't. We've got 2 numbers for a position, 3 numbers for a colour. What's going on? Well, let's just say our GPU isn't stupid. We haven't told our GPU that we are going to be passing it 4 numbers for a position and 4 numbers for a colour. We haven't told it that. Our GPU, if it receives only 2 numbers for the position, it will fill in the other 2. It will fill in the other 2 with 0.0f and 1.0f. The 1.0f being a homogeneous position for the 4th dimension. This is categorically used to fix our point of origin within the mathematical calculations that are used upon the GPU to do all of the vector and matrix calculus stuff. The black box of magic jiggly numbers which we are not honestly interested in. Again, on the colour, the 4th value, if not supplied, will be automatically set to 1.0f, which is the homogeneous number, but it also happens to be 1.0 alpha. That's a handy coincidence, but it's not a coincidence. That is why alpha values are 0 to 1. Sorry, 0.0 to 1.0. And represent a percentage of visibility, how see-throughable, or sorry, how solid something looks, with 1 representing 100% solid, 0.0 represents 0% solid, we can see through it. That will be automatically put in for our colour. We're using solid colour, we're happy, we don't care. We can change this and pass in partial visible colours. Tints. But our GPU does that automatically for us. That's kind of it. So how does our program know to send these as separate? Why is this not bleeding over? Why is it not sending 4 and then 4. That's because somewhere we've got a description of what we are sending to the GPU, and the GPU is looking at that description saying, ah, yeah, well, if Eve sends two values, we know that that's going to be here. He's telling us that he's only going to be sending us 2 values, so we'll use that for this position, this layout location, 0. And then somehow we are telling our GPU we're only going to be sending 3 numbers in for location 1. And that's why these locations need to be known. These are pointers within a vtable on the GPU. Don't worry about it. You can look them up in OpenGL. Not sure how we're going to react to this in our lovely Vulkan right now, but we do it. Somewhere here we are initializing our resources. We have some buffer information. We create our buffer with a memory, and we allocate some information here. So really all of this is doing is measuring the size of the data and making sure that the buffer is the correct size that we allocate on the GPU that can hold our data. Otherwise we're going to get things like buffer overflow and buffer underflow, both of which are not desirable. Size usage is a vertex buffer and a uniform buffer. So basically we're stuffing everything into the same buffer. Alright, we need to describe this though, the contents of this buffer somehow. Assign data to the GPU. Map the memory. Okay, we copy the data over. We are going to do something very, very interesting in a second. It's going to be funny. Data for the shader uniform variables. This is just setting the uniform variable, is it? We have a matrix. We memset our matrix. No, we don't. We memset the buffer info. I'm going to put a Control F on that because I'm not searching for it. I'm sorry. We just memset it. Not new, but memset it. So we're doing C, not C++. This is a line of C code. And it's also per frame count. We've got 3 frames. And for each of the frames we are setting up the buffer, the offset and the range. And there is your matrix, the constant data, and we copy 16 times the size of a float, because matrix, a 4x4 matrix is 4x4, 16 times the size of a float, which is correct. And that's just going in. That creates a data storage area for that variable. Remember, the buffer is only data storage, it is not programmed. The program is the shader. Right, so at this point we have no idea until we come to this. And this is where we describe to our GPU what the hell we're doing. So the following describes to the GPU how how we have arranged our data for usage in the shader programs. So we are binding the vertex input binding description. So we have a vertex binding description, which is an area of memory which holds the details on the GPU of how our data is arranged in our buffer and how much the GPU should accept for each location. These locations must match up with your shader program. As you can see, we're telling the shader, hold on a minute, this isn't that format. Well, we don't want that format. Let's change it. We want 3 numbers. We want 3 floats for our position. We want to add our Z coordinate. Here, this is going to be a... Is there an A32 here? There is. So it's just A32 we add on the end. Thank you. That's obviously... Because we want 4 numbers. We want to add our alpha ourselves. Anything you miss off, because we haven't put the alpha here, it will still put 1.0 at the end. It will add that itself. This is telling the GPU what we're going to supply, and the GPU, with anything that's missing, will supply its own value. If it's one of the first, if it's part of the R, G or B, it will supply a 0. If it's part of the 4th, it will supply 1. It can only have 2 values, a 0 or a 1. It's binary. Even though we're using real numbers in this case, those are the only 2 values that a computer can assign automatically. Computers cannot deal in real numbers and cannot calculate in real numbers. They can only use binary. So those are the only 2 values that it can assign, and those are the 2 values that it does assign. And that's why the homogeneous position value is 1.0. You're thinking, why isn't it 0? Because then it would be the same point in space as our 3D object. And that would complicate all issues, as then all 3D objects within a scene would then be joined together at the origin. This would create a mess. Don't do that. Let's put it to position 1. All of our objects can then be in the 4th dimension, or the first of the 4th dimensions. I think that's a better way of putting it. That isn't intersecting with our 3D visual display, but does allow us to do 4-dimensional calculation and maths. That's the reason for it being 1. It can't be any other number because a computer doesn't have any other number. There you go. That's the reason why the homogeneous position is 1.0. Convenient, but true. If you do want to get into four-dimensional mathematics, I'm quite happy to do so. I can juggle that quite nicely. So now I've just changed these two. What's going to happen? I've just described our data differently. We're not going to get a triangle anymore, Bob. We're no longer in Kansas. Look what happened. We do get our triangle. But how? Something's not quite right. Can we make it so that our triangle comes back to us as what it was before? But that's an interesting result. This is the most interesting. I've not done this experiment, by the way. This is the first time I've seen this. And that is more interesting to me than anything else because of our initial data set. Holy crap. I want to see our initial data set now. That's amazing. It wasn't supposed to do that. It's counterclockwise. That's the front. That's the back. It's not culling. We have red, green, blue. It is going counterclockwise, is it? It's an optical illusion, remember. You see that point there is spinning around to the right as that way. This point here, however, it could be spinning around this way. The rotation is non-defined. If you look very carefully and focus on one of these points at the bottom, either the green or the blue point, you cannot tell which way round it is spinning. If you look at it going anti-clockwise, it will go anti-clockwise. If you watch it go clockwise, it will go clockwise. It's an illusion. There is no 3D. This is a flat screen. All of 3D programming is about creating the illusion of 3D on a flat plane. Oh, our FPS came out right. Fantastic. So this, we don't know which way around it's spinning at all because it's incorrect. Is that going clockwise or anti-clockwise? It seems to be coming towards us and then going away from us, but is it? Is that actually happening? Is that what the calculations are doing? You can't tell from that result, and that's why I said, oh, I've never seen this before. This is interesting because I know that all of 3D is an illusion. And we'll come across that on Sunday because I've got to talk about it. The Illusion of 3D. We've found the title for Sunday's talk. And it's a big one. Can we just note that down? I don't do programming on Sundays. I take the day off. Where are we? Okay, we're here. Okay, we did bugs. I thought that was a good one. Let's have another one. Why is this so... What the hell happened here? Something's gone wrong here. Why is this all the way, the zoom level all the way out at 6.73? Interesting. Okay. So for this Sunday coming up, advertisement. You lot think I prepare all of this. I don't prepare a damn thing. The Illusion of 3D by Blades. I'm going to give that a straight and a wiggly. That tells me I have not prepared the speech or the chat. I don't call it a speech or a lecture, I call it a chat. I don't profess to lecture anybody, and I will never teach again in my life. I hope. I'm going to put that there for me to come back to think on later. Okay, sorry about that, distracted. So we've just had an interesting result because our data doesn't match up. We are now passing through a 3 and then a 4. So how does our data look? We do have something here. Get rid of this mouse, god damn you. We have one of these. We do have one of these. Where can we go? We'll just do that. We'll pop over here. We'll open a file. And we'll call it Scratchpad. Because I don't really want to keep it. We'll call it text. So it doesn't give us any stupidity. This is the data we've got. Let's just pop that into our Scratchpad and give ourselves a little bit of room to play with. Okay. It is going to format it and try and make it into code, but hey ho. Microsoft is stupid. They don't understand what text means. We have described it as... I'll have to come back up to full now because I can't see. It's the green bits here. We have described it as this. This is the description that we've used. That's the whole command, is it? Yeah. So position binding 0, location 0 and location 1. Okay, let's pop you in here. And that's the process that we're going to use on it to find out what the hell we've just done. Alright. So, let's have a look at our data set. Our data set no longer looks like this. That's how we displayed it. However, we didn't remock it. Did we not remock it? We might be able to get a different result. Sorry, I just had a thought. Oh, let's rebuild. We might be able to crash this. No! Wow! I'm stunned. What you are seeing on screen does not exist. That cannot exist from what we have done. Because this is what we have done. We have told it that we are going to send it an RGB. So the actual first number it receives should be that. And it is that, actually. That's the first number it receives. The next number is RGBA. So, this is so damned interesting. How the hell did it keep the colours? Is it because the next, I think it is actually, the next 4 numbers oh wait a minute, we should tab it over, shouldn't we? That's your first line of data. And it's not showing that. The colour should be 0.0, 0.0, minus 5 with a minus 5. That should crash. Or it should at least place those automatically to 0.5 and 0.5. I don't think you can have a minus colour. Somehow. Hard to tell. That first point in space is red. And it's staying red. At no point have I said that it should be red. That's what I've described to it. So something else is happening here. It knows that our data is coming in, but it also knows not quite everything. I think this one is this offset. The Z offset is pulling this towards the camera. Yeah, GB. So yeah, that's being pulled towards the camera by 1 meter, causing a 45-degree plane of existence. So that's correct. What do we get for the now the colour's coming through correctly. It then resets itself for the colour. Picks up the colour correctly. And we put an alpha value on the end. We send in an incorrect alpha value. RG. G should be see-through. And then we have feck knows what. An overflow error. G doesn't look see-through to me. Actually, it could be. Can I freeze this? No, I can't freeze it. Can we stop the animation, please, Bob? The animation was there to show you how things cock up. We have a run. We won't be able to see the red offset, obviously, because it will be straight up. Is that green see-through? No. It should be. It's not a oh, it isn't a minus sign. It isn't an erroneous value we're sending in, is it? On that green? No, it should be 4. So it's not doing that. What it's doing is it's going along and it's realizing for itself that that is the position and that is the colour. The only thing it's having problems with is, well, luckily, we've got a 0 here and a 0 here. So only that one was placed out of position. So this part is working. When it comes to the colour, though, it's resetting back to here, and it's reading in the colours. But how's it doing the alpha value? We're not reacting to a blend, are we? So we're not actually using the alpha value within any calculations inside of our shader program. The alpha value is being ignored. We are passing in the wrong values, and it doesn't matter. So it's taking the first 3, it's passing it through. It then resets and starts at that point for the next 4. So now we know how these buffers are being accessed. We have to work out how we can control that. I'll keep that. This is the reason why we have this rotation on, by the way. For exactly seeing that 45-degree angle slope, and that the displacement on the first one is real. We are affecting the program. This now becomes interesting, because what we would have automatically done is the following. And this is going to wreck our program, by the way. Okay, we would have put in the correct data. Which would be what happens, do you think, when we put in the correct data? This is what we have said we are going to give it. What happens? Oops, sorry. Remember, we wanted to add alpha values and we wanted to add a Z. This is an interesting experiment, because what happens next could be very interesting. There we go. That's it. Beautiful. Thank you. You don't get what you expect to get. You get something very, very interesting. And to debug that is next to impossible for a beginner, because they don't know what we've just found out. A beginner 3D programmer would look at that and say, that's nothing to do with that data. That's a simple triangle that we wanted on screen using 3 X, Y, Z positions for each vertex and an RGB colour with an alpha of solid. And look what we get. Can I blow that up a bit better? Because you can't see one of the pixels. I'm gonna we have to change the background color. We will change the background color to something. All right. We need to change the back. That's the first thing you do. Okay, when you get something like that and it's not obvious, change the background color. So the first part of the problem is we can't really see what's going on. I know what's going on, but that's beside the point. Where's our background color gone? It's under rendering at the bottom. It's here. We only saw green and blue. So we'll take U out of there and we are going to put a red background on now, as we didn't see any red. Okay, that's a bit more descriptive. I still don't see any red. Alright, so that is what it is. It's black to blue to green. So what we have there is a zero coming in. Of course it will, yeah. It's obvious from your data. Let's pop the data up, get you back on screen. The 0 is here. There's no red. So we know that the only way there can be no red in all of this data is one line, or one part of the data is not holding a value. So that is being used for red. That's being used for RGB. Right, you've got it so far. That's being used for the alpha, is it? No. The alpha's being used for is 1. That's being ignored. And that's being ignored. The problem is it's still handling the data as 2 and 3. Then it's going for 2 and 3. 2 and 3. Do you get it? But it's resetting, isn't it? So it's actually going 2, 3. It is resetting to that one. No, it isn't. Where's that next position? That's the first position. We have to stop the rotation because I don't know where the second position is. Again. Let's find out where the second position is. Ah. The second position is directly away from us, or towards us, is the answer. We know it's there. So that's 1, 2. Then it would take on 1, 2, 3, 4. Then it's going 0, yeah, 0, 1. So that's the second position. That it reads out of the buffer. Because it thinks every line is of length 5. So somewhere we have to tell it, hold on a minute, it isn't 5 anymore. It's 3 plus 4, that's 7. And that's what we haven't told it. We need to tell it now that that's the error, basically. We showed it visually. If you hadn't had the rotation on, you wouldn't have seen it. Because the error transforms the triangle into the Z plane. And as there is no depth to the triangle, it's not a 3D object, it's just a plane, you are looking at the side of the triangle instead of the face of the triangle. The object disappears and the person thinks, oh, the rendering isn't working. No, the rendering is working. The data is not being described correctly. Can you see the trip-ups of what you might think? If you do 3D programming and you don't see something on screen, it doesn't mean it's not there. It usually means it is there. And it is happening. It's just that you're looking at it from the wrong point of view. And this leads directly into Sunday's talk, obviously, now. So we now know that programming 3D is one, we're creating the illusion of 3D. We're not actually programming 3D, although we have to do the 3-dimensional and 4-dimensional maths to create this illusion. It's a mathematical illusion, and to be able to display 3D on a 2-dimensional screen. So we've learnt it that far. I'm teaching you more about programming than you'll ever get at a degree course. In fact, I'm teaching you more about programming than if you were to go out and learn the history of programming today. These are insights. These are not necessarily what people will teach you. I am not trying to teach you. I'm just trying to give you some insights of what the hell's going on here. Computers cannot do what we think they can do. And I think we've already just proved that. And this is why the operating system's so goosed. Right, so we now know there's something going on here. We know that we've changed the length of the line and everything's gone a slightly foobar. So I'll just switch my rotation back on. We've got a nice effect out of that, actually, one that could be used. So it's not to do with that description, is it? No, that's what we just altered, and we got a complete foobar. But we got an interesting one, and then we altered the data to the correct data, because we realised the data was wrong, and it went completely wacky. There's a 5 here. I wonder what that 5's about. I wonder what happens if we turn it to a 7. We have our original triangle, but we still don't have red. We have something quite strange on our colours happening. Our colours are now not responding properly, but I don't know. It is, yeah, we've still got a black colour happening. That's interesting. Again, can we stop that? This is going to be interesting because I don't know what's going to happen. So stop the rotation. Find out what you're looking at. Oh, we are looking at at it, but it should be R, G, B. We're getting green, blue, doesn't exist. What happened to our R value? Is our data correct? It's not picking up on that, is it? So where's that? So G is green. It's picking up on that. We're getting green from somewhere. So it's picking up on that, and then random. No idea, buffer overflow time, I think. Why is it not picking up on... I mean, the points, the positions are correct. I think, yeah, they are correct, yeah. But it's missing this. Did I type it in wrong? Why is it not red? Why is it green? The position's there, the red isn't. That's an interesting result, one that I wasn't expecting. Every time I do something like this, I get different results. It's like the chaos theory. A small equation will have massive permutations to the extreme that all equations can cause chaos. Once you know that, something like this is perfectly acceptable as a result, but it's not the one I expected. Blow that up a minute. Is that a red pixel at the top? Is there a singular red pixel there? Background choices, background choices. Let's turn our background off. I was doing that to demonstrate that there was a black point here. So we know there's a black point here. We can see the shadow. But it's making that up. We're not passing that value in. That value is made up. God knows with what data or who by. Interesting, but it's true. Alright, for the first time, I'm going to go into a black background, which I don't usually use. I'll just exit out, please. And I'm trying to shadow it all off with my mouse pointer to get a contrast. But my mouse pointer is surrounded by white. That top pixel in the triangle is green, not red. I'm not sure what flavour of green that is. It doesn't look like green to me. That looks like blue. I'm not sure that that's green. I don't think that it's actually matching that. I wonder if it's still doing that. G, B. It is, isn't it? it is green. It's still resetting, going back and reading those three. So it's reading down that line. So changing that 5 to a 7 has helped, but it hasn't given us the desired data input. So there must be another 5 somewhere in our code. Well, there isn't. Is there? And I knew that before I even did it. There is a 2 within our code that should now read 3. Let's try 2. Okay, that's your descriptors. That's where we change the 5 to a 7. So what that line there says, A is 7 times the size of a float. That description means that we are binding buffer 0. So in our buffer 0 is comprised of 7 floats per vertex. That's what it says in English. We then went on to describe these and change the formats because we wanted a 3-4 format, not a 2-3 format. Two times the size of a float. Well, it isn't, is it? It's 3 times the size of a float. There's 3 floats now in front of it. Oh. Where did I leave it? My number 2. Number 2, come back here. I left a number 2 hanging around, didn't I? Here it is. Sorry. RGB. Background can be replaced. Everything works. We are go. Or are we? Yes, we are. We now have our original program modified to the data set that we are going to be placing into the buffer. I don't like black backgrounds. Black backgrounds are dangerous because you can't see black pixels. And black pixels often mean there's an error. We'll just tint it. Just tint it back to blue, please. We are now at 2:20 and I've earned a cup of coffee. Our new data structure is complete, or is it? We've talked all the way through it. We've gone through the thought process that went behind it, which is completely different to anything that anybody expected, I think. I'm hoping that if you are wishing to learn from anything that I do here at the Games Club, that these thought processes that I'm trying to verbally describe to you are going to be more helpful than any code that I can give you. And on that bombshell, I'm going to go and put the kettle on. Okay, just run it over in my mind. That buffer's correct. Lovely. We can tick that. Did you see how I debugged it though? I didn't even press the debug button. I just went through the system. I didn't go through the program. That might interest a few people on how to debug their programs. The conclusion to this is that people believe that programming is about learning a language. That is not how you learn to program. You learn to program by understanding what you are typing in and how the computer works. The language is irrelevant. I can write this program in any language you desire. End of conclusion. Does that make me a programmer? Oh, good. It knew. Right, I'll go make that coffee now. I've just taught the whole world how to program a computer by accident. Whoopsie daisy, I shouldn't have done that. Oh well, I've got my coffee and I'm going to enjoy it. We can continue now. We accidentally diversified off into the reality of programming whilst in the middle of loading our model, and what programming really is. 277 Aldo. Alright, complete the render pass. It is the last thing to do. What time are we on? 2:30 in the afternoon. Well, 2:25. Just 1 sec. Let me just get my mind prepared for the rest of the day. We might do a talk. I mean, if anybody comes on stream and says they want a talk doing about the next subject matter I'm about to give you, you just get that eraser up. Thank you. Just clean that up. There is an optional talk today, if you want it. It is Saturday after all. The talk would be Qt and C++. Because I've been asked the question, and it's a double straight line. There's no iffiness about this. A wiggly line, by the way, means there's some iffiness about this subject. Yeah, that's the only way I can explain my language for this notation that I use. So we'll leave that there. We will go back to our Vulkan. Do we want this completing? Complete the render pass. I don't know if I can. On what we've got. I can try. We've got the buffer dimensions correct. Do we do the rest of it? Do we need to do the rest? Anything else? Let me just check. Review time. This is pass 1. This is all experimental code. Go back to where we were. There may be something I've missed. 7. We've changed it now to 7 floats per vertex, and that the colour is 3 floats in. It's the next one after. So that moves that correctly now. We're getting the correct colours. Vertex input info, flags, counts, its layout. That's just setting up all this information on the GPU, isn't it? Layout and binding. We don't need to change the matrix. MVP, when our projection matrix doesn't need to be changed. We can leave that alone. I'm just double checking myself. You'll see that I do this a lot. It's not that I don't trust myself, it's that I don't remember things. Okay, pipeline layout. Shaders, we're okay with that. The pipeline itself looks good. Stage counts 2. That means there's a vertex shader and a fragment shader. That's all that we're going to be running in programs. I think that's what it means. That's my interpretation of it. It's probably not correct. Don't take that bit as fact. That's just me thinking about it. Okay, whatever. It's irrelevant to what we're doing right now anyway. Scissors. Fine. What's this part? The rasterization. The rasterization is where it takes the result from the fragment shader and then checks it against all of this crap here to see whether it becomes a pixel. That's why it's not a pixel shader. You don't have a pixel shader. You have a fragment shader. Your information becomes a fragment. That fragment is then processed to see whether it gets displayed or not. If it gets displayed, it becomes a pixel. That process is called rasterization. Depth stencil is the way it checks the depth to see whether the fragment that you have created is obscured or hidden behind something else. Therefore, it will be discarded. It will not be rendered. It does not become a pixel. Color blending is obvious. We've already said about the alpha value. It says here, no blend, write out all of RGBA. It is correct. I think. We'd need to look at that more. There's a formula that you use that we would have to look at. Okay, we've got full dynamic state on the viewport, which means we can make the window bigger or smaller and it will adjust everything for that. Swap chain resources, don't care. That's just how the system works. Starting the X-frame. I'm still not 100% certain about the render command and how this, if that is swap buffers or not. I'm not certain about these notes I've put in. Those are my thoughts. Need to be researched. We should really look them up in the manual, but I'm not prepared to do that at this stage. I'm ready. We'll try it. So how do we insert our model for this data? Well, simply put, we take this data out. There you go. We have our model ready. It's here. Okay, I've put my notes in for the model, and we have printed out what is contained within that model. We can see that on screen in our application output, which we haven't got available to us right now. So we can see the data, and we can see that our data does align up with this data now, which we have changed and modified the program to accept. Everything should be set up and ready. But size of vertex data. Well, our data's in the model. Let's be naive. It's come through as a pointer, has it? Yes. There's our data. Okay, it's accepted that. That is not an error. We need to flag this as a change somehow. So line 106 change. Okay, this is where I need to start making notes. So we do have a text file here doing nothing. So a change to our model data. We are in Vulkan rendering. My notation for that being a thing is to place it in square brackets. That's private notation. It's got nothing to do with programming or anybody else's notations. So we're in there. We are on a line. I love doing this. 106. Change that we made is to the size of the vertex allocation. Size of. Replaced size. No, just oops. What the hell was that? Print screen. Oh, well done me. So size of, and we can't use that. What symbol can I use? English. Replaced with our model data location. Now, is that going to get the size of our model data, or is that going to get the size of an address? We hover. Value equals 8. Alright, so that's not very good. Let's try a dot size, maybe. It returns a value. Returns the number of items in the list. That's not exactly what we need though, is it? It needs a type def in here. Let's remove that a minute. That returns a queue list. It will take the size of a queue list full of floats. Will that come back in bytes? Yes, it will. That might work. Hell, it might work. Let's go down to the next one. Here we go. We're now going over to memcopy, where we take the data from our model. This is 139 now. Okay. So line 139. We are going to be replacing model data, and we are going to have another size of model data. Now, size of is an actual command in C and C++, whereas everything else is usually a function. There's only 15 commands in C, 15 actual commands. It has been expanded upon to about 30, but most of that's just type defing. Don't worry about it, they're not real commands. Size of is a real command, one of the only ones there is. And what it does is it returns the number of bytes in a memory that comprises a buffer. a physical storage area. That area has to be type deffed, which is the other command that goes with size of. So those are the two actual language constructs that make this work. So we're going to take our model and we are going to give them that, I guess. And here we're going to do exactly the same as we did before then. We're going to give them our model. And we're going to give them that again. Oh, we got something. Call operates on objects of type QList float, while the size is based on a different type, QList float star. Did you mean to dereference the argument to size of and multiply it by the number of elements? It's just told you the answer. Like I said, it needs a type def in there. So the actual type def is a float, because that's what we've got storing. And it says, did you mean to multiply that by the number of elements? Well, the number of elements is here. Is it not? Yeah, it is. Oops, sorry. There you go. Returns the number of items in the list. So that's the number of elements. They're all floats. That'll do me. So this is float times num elements. Okay, looking good. So why isn't the first one that? And should it be? The answer says I think it should be. If that's a mem copy, why did it not give us that error on line 106? Does anybody know? Back here in line 106, we didn't do that. We've just put size of m model v storage. And it's not an error. The reason it's not an error is because it's not a direct command. It's inside, or it is something being passed to this aligned function. This aligned function is not necessarily asking for that. We need to look at that aligned function and find out why this isn't giving us an error. Here's the aligned function, because the aligned function is looking for a VK size V, which is a uint64 underscore T. It's got nothing to do with size of. It should not be asking for that. It should be asking for the type and elements. It should be asking for the data. So that's misleading. That's got nothing to do with size of. A uint64 is not what size of gives. Size of gives an unsigned long. Psst, that's the same as a uint64, by the way. But don't tell the computer that, or the programmer. Just because it is of the same type def at its very basic core does not mean it's the same information. And this line is proof of it. This line is wrong. And I'm going to leave it wrong. Yeah, pretty close. Pretty damn close. To understand what you're seeing is a little bit more complicated. And then I can go through the thought process if you want. Let's see what happens though if we now change this to the size of a float. This is going to be interesting. You'd probably crash it. Float multiplied by m. Well, Control V, M model, dot size. Now it's let me do a dot size here, but it shouldn't do. It should be that. Don't know why it'll let me do a dot size there. Doesn't show anything. So the correct answer is we had it right. This is interesting because the correct answer is not that. The correct answer is that. That is so counterintuitive, it is fecking untrue. Hey, where are you going? Oh, Godfathers. Give me my comma back. Thank you. There's the correct answer. It's nice, isn't it? That isn't what it was showing last time. Oh, wait a minute, we still have that data change problem, don't we? Oh, yeah. Right, we need to do a rebuild. Before we continue with this. Oh, beautiful. Yes. Right, convert to Blender, malloc, blah, blah, blah. We have a resizing going on that failed. Could this be line 106, do we think? Shall we step over? We should have a memory location. Okay. Here it goes. Come on, crash on me, little creep. It doesn't always crash. Okay, there we go. On 127 of the allocator. Well, I'm not blooming surprised. Where is that? It came through malloc. Threads, maybe? rendering 474. Possibly. Q failed. Da, 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 da. Okay. VK map memory. Yeah, our buffers are not the right size. So yeah, that is a problem. Okay. So we didn't do a mock. Can you stop running? Thank you. I hate debug mode. Alright. Let's put it to the correct value. So line 139 has the correct value. Which is that. Stop it! Oh, for sake. Computers are getting too fast these days. That's the piece of code I want. That should be in 106. It has to match. Whatever's in that has to match in 106 here. You can't have something different. Right, that should be a uint 64, but what is it actually going to give? I think it's going to give an error. Oh no. Interesting. Is this a Q object, this renderer? No, it's not. Shouldn't be affected then. It could be. It is a Q object. Damn it. That presents a problem. Possible. That's better. It shouldn't show anything. Oh, thank God for that. I was worried for a minute. There you go. There's our wonderful model now being shown on screen. Isn't it great? It's a lovely model. It's a model of a blue background. How come that's not working? What's going on here? Things aren't exactly what they seem, are they? Something's going on here. So firstly, what is this producing? An unsigned long. Okay, what is required? A uint 64T. That's what's required. I'm pulling you down to the next line. I'm also going to put you in brackets. What that is producing is feck only knows. So I'm just going to put in a static cast, mainly uint 64t. There we go, that's that done. I want to separate those lines. Unknown type. Okay, it's 64 underscore t. Yep, that's okay. Alright, so I think we've got the correct thing there. I also would prefer to be doing that for the other one. Here. Memcopy, however, is looking at a void. And it's looking at a size t, which is basically a void start again. I will try changing that and see whether we are allowed to. We are. So I can now guarantee that they're both in the same format and they're both going to give the same result. The interesting thing that I would like to do is know exactly what that result is. Am I really that bothered? Yeah, I'm bothered. 106, we will go to 110. Okay. It's libraries. Blah de blah de blah. Here we go. Here we go. So this is coming under M model, isn't it? Where's this? Here you are. Just open you up. We'll find M model. We have the model matrix, the number indices 36. Notice there's a number here, 36, next to number of indices. In the VBO storage, it will also give us 259 items. So what's 259 divided by 36? Or the other way of looking at it is we have 7 items in each vertex. What's 36 times 7? It's 210 plus 6 times 7. What's 6 times 7? 42. That's an interesting number. So that would be 252. We still have 7 items left over. And that's because we start at 0. The indices start at 1. Should that be size -1? That's very interesting. Hey, said who 12. Sorry, I've been concentrating on what's I've got up on screen. You'll find this with me. You'll put something in chat and I'll blur. I'm doing Vulcan. Yes, I am. Just for a laugh. I'm actually doing this for fun. As you can see what's on screen, I'm not overly keen on the way Qt's handling what it's doing. So that should be returning 259. And it's not telling us. Alright, I don't like the way it's doing it. Breakpoint get rid of. Program finish. I hate debugging these rubbishy thingies. Just ask it the bloody answer. Right, let's ask it the answer instead, shall we? Q. Debug. This is not what you're supposed to do. You're supposed to try and understand it from that point and do a little bit of work on it. I don't care. I'm going to put a \n in. Now we've got that key, we can do it. I'm going to take that, copy. I'm going to put it there, and then I'm going to put equals. That. No, don't do that. Let's have another \n in there just to separate it off so we can find it in the text, in the wall of text that we are now getting. I know. Bad news, isn't it? Hope everything's going alright, said who 12. This has been an interesting journey this week. Today has been one of the most interesting journeys I've been through in my mind, and I think we are going to come up on a talk about this now as we head into 3 o'clock. I'm just interested in what the hell this is doing. Okay, so that's the piece of code, that's the readout, and that should come up in our output here. Let's get our output ready. We will clean it. There we go. We are getting this black box back again. If you watch very carefully, you will see it is rotating. It is actually there. This is actually our model. So when we just didn't get anything last time, we'll go into that some other day. Right, static cast uint64. This equals 1036. That number means nothing to me. So we're going to take away the multiplication part. 1036 seems a bit high, does it not? 1036, isn't that 4 times 300? Four times 200 and... let's find out. Right, just taking the size off, the multiplication out, to find out exactly what is this giving us, this part here. Told you this was interesting. It is to me anyway. I like playing with what people give me. Okay, our little black background has stopped. It's no longer rotating again. Never mind. It can't help itself. 259. The magic number 259 has appeared. I am not going to count them all to find out whether there are 259 here. $259 floats would be times 4. That would be your 1,000 and whatever bytes of data. That's correct. The fact that we've wrapped it in a static cast to make sure it's a uint64, it's got nothing to do with anything. It's because it's being passed into here. When we come down here, however, we're okay. We've done it. That's the correct code. There you go. Let's just have a look at that output again. Yep, those are correct. I'm interested that it's 0.51. Oh yeah, that's because I added the extra millimeters, wasn't it, for the base? The base is bigger than the top. So you have the top, which is 1 meter square, and then you have a secondary layer underneath, as it's a cube, a flattened cube. The secondary layer underneath, the catching layer for people falling through the floor, is 1 centimeter bigger than the 1 meter cubed at the top, so it is 0.51. That is correct. We still have this positional error. On the last item, where it joins everything up onto the last position. That position should be 1 point... no, that should be 0, 0, 0, and it's coming up as a real number, which means it's not joining up precisely with the first point. Why is there a 0, 0, 0 in there? That's its location. That shouldn't be there. That's an offset. If you remember, we didn't actually place anything at 0, 0, 0. That was the center of the top surface. There isn't a vertex there. We've got one item of data too many. Our data finishes here. Oh, that's why I was puzzled when I saw the number 259. 258, yeah, I can understand that. 259? Doesn't make sense. We've got one item too many. That's our first mistake. So our model loader is giving us one item too many. Done. Again, I'm going to do a rebuild. I'm going to keep doing rebuilds because we're sending data to a graphics card. That data can remain there. Doesn't matter what we do. The graphics card can keep that data for until the computer gets switched off. Without switching the computer off and back on again, I can't clean memory effectively anyway. So by running the program, we can be picking up on spurious memory, maybe. There we go, we get nothing, that's good. Now we're getting 252. 252. That sounds more like it. That's what I was expecting in the first place. Our data now doesn't have those awkward last numbers of zeros not being real. Sorry, those real numbers at the end. We now have pure data. We still have nothing on. We do have something on screen, by the way. We do have our model. It is revolving. It is there. It's just the same colour as the background, unfortunately. How can we change that? Could we just switch off? Oh, no, we would still see it. I'm going to switch off rotation. I've got a feeling about it. We know that this changes the behaviour. Oh, wait a minute, we have to rerun it, don't we, as well? To get the black thingy. There we go. There's our black thingy. I'm just trying to prove to you that the model is loading, it is on screen, and it is showing. It just isn't quite knowing how to display itself at this point in time. Or is it? That, by the way, is the motion of it turning around the y-axis. The actual animation that you are seeing is the animation that we've asked for. It is correct, that animation, for what we've done. That's why I wanted to just turn it off. Why didn't it show the first time, and why does it show the second time? That's the biggest question you've got to ask yourself. So let's just change you to a 0. Let's get rid of this. Nice rotation that we've got going on, and again it doesn't show. But let's just run it again. And now it doesn't show at all. So it's only showing for certain rotations. Now we know something about the apparent mystery. Let's just pop you back to 1. It may show. Yes, it does show. Will it show every time? No. No, it won't. Doesn't show. No, it doesn't show again. Alright, so 0 could be a repeated. This is called undefined behavior, by the way. I don't know if I can get this to work. We'll have to do a rebuild. We need a specific piece of undefined behavior. No, we haven't got it there. I don't think we're going to get it. Let me just work out where it is. The object is here. Literally in this space here. Okay. What we are getting, however, is the object being viewed from the inside. Which is one, why we're not getting colours probably. And two, why it seems to be this thing going like a big block. We're only seeing a square pass by. Which obviously gives you the indication that something a bit weird's going on. We'll have to keep the rotation on there. And we can't see it now. It's going to be very, very difficult for it to be seen because it depends on the rounding error developed by the clip plane. We're not going to get to see it, are we? Damn you. Just wanted it to be seen once more. We have to do a rebuild to reset the rounding errors. There it is, thank you. So I know it's to do with the clip plane. I know that it's to do with the calculations of the vertex positions. And I also know that we are inside the object. And that the camera is, yeah, inside. We should reduce the clip plane. That might help. That could work. I know we're too close to it because it's filling the screen. And yet nowhere does it tell us in our data that that should be happening. Our data is coming in at 0.5 to 5. So at most it should fill half the screen. Which means somehow we are on top of it. We have a projection matrix. Should we give... I think we're going to have to give this an MVP. It makes sense. Hell, I don't know which way round Vulcan is. See, in matrix calculations, the multiplication of three matrices, the M, the V and the P, the order in which you do those calculations matters. So our point of view is at 0. We are looking down the negative x-axis, I believe. Y is up, and that means we can construct an MVP. Our program has worked. It is complete. No, don't do that. I want it to complete. Otherwise we might be... So yeah, that's correct. It may not be what we intended to program, but it is in fact what we have programmed. So the intended result is correct. The computer is doing exactly what we've told it to do. But we didn't intend to visualize it that way. we intended something else. We intended to see the object at a distance. We have not placed the object at a distance, and therefore that is not the intended outcome of the program. It's worked. We've done it. There you go. It's interesting, isn't it? How people can mistake what you are seeing as output from a 3D program as erroneous. It isn't at all. It's what you've told it to do. We can just move it inside the shader. No, don't do that. That's lazy. So we've done it. We have completed. That's enough. Our model is now displaying, although our camera is inside the model. Ironically. So it's not displaying very well. Okay, so we have actually completed that. Complete the render pass. We have done so. So that has been done. That gives us a new step of move our model into a viewable. I'm making up English words here. Viewable. Is that an English word? I have no idea. Position. So that we can see it. Via a camera. There's two parts to it. There's a camera and there is a location. We've already got a projection matrix, so our camera is set up. That's your projection matrix, and I'll just put in MVP. So we have MVP, which is model view and projection. Projection we've already come across. That's your camera. Is it? No, projection is projection, views your camera. So we haven't got the camera. So, I think that's right. Don't quote me on this. I cannot remember off the top of my head what all of this garbage is. This is the position. It's sometimes not called a model matrix, it's sometimes called a position matrix, but it isn't position at all. Although that's what we're going to be using it for. Now the reason why we're having a problem with this rotation thing is because it's not the model that's rotating. We'll come to that. We are not actually rotating the model, and mathematically we are not rotating the model at all. The model is static, it's stationary. The fact that it seems to be rotating is that we are moving the projection. We are rotating the projection. We are orbiting. That's damn dangerous to do. And it's a bit weird because of the way we've done it, that it's possible that we're not actually orbiting and the model is rotating and we can't tell. So we need to start defining MVP. We need these three matrices to start working. Otherwise, we have no control over what is happening within our scene without those three matrices, because that's the only way we can calculate what we actually see. So the model will then have its own control unit. It will have its own position, its own rotation, its own scale. The view will be a view from to. Yeah, a view from a position, looking in a direction, rotated and scaled. The projection matrix is how the lens reacts and the frustum. So I'm going to put frustum in there because that's what that contains. How we how we create the illusion on a 2D surface of a 3D world. That's what the frustum is. It's the calculations for the illusion, basically. And it's a very simple calculation. All you do is you compress the whole scene down into a little box, in a formulaic way. And by doing that compression, you then pull the top, which, remember, in 3D, looking straight forwards, you see it at an angle upwards, you see it at an angle out to the left, you see it at an angle out to the right, and you see an angle going downwards. You do not just see straight lines. Your viewpoint is not using parallel lines. The frustum calculation takes those lines that are going out at angles, we've chosen 45 degrees for our projection matrix, and it makes them into a parallel line so that it's in a box. Once it's in a box, we can squash that box from back all the way to the front. And when we get to the front, which we set to 0.01, well, 10 centimeters in front of us, we will know the size of every object and what is behind what. That's how the frustum works. So the frustum is the calculation of taking what a 3D perception is, where things go out at an angle, and turns it into a box where things go at where things all come into a box. So what it's really doing, I'll draw it. It's taking, there's your camera, or your eyeball, whatever, we'll make it an eyeball. It's often represented like that anyway. It takes that, the frustum is the calculation of going from, we said 45 degrees, didn't we? I'm not going to get 45 degrees out of this. But remember, it isn't, this is 3D. Okay, so this is a 3D photo. It's a circle. Don't really need dots. So it's taking those two lines, and what it wants to do, where does it happen? I think it's here. How does this tilt work? Where is the tilt? I'm going to put it here, because I don't know. What it wants, and what it does, is it tilts those two lines to being parallel. That is the objective of the frustum. And the projection matrix, that's what it does. This can then be enclosed. That can move that way. And what you do is you get a 2D plane with everything being drawn upon it, and that is the buffer that goes to your screen. There's a lot of analogies going on there, and that is not exactly what happens, but it's close enough for a biscuit to give you an idea of what I'm trying to talk about. Whoopsie daisy. That's the closest approximation that I can give just off the top of my head without actually thinking about it properly. Right, lovely. Discussed. So that's what we would need to do next to actually get to see our model. Neat, huh? And that's the last part because this is not what our program is about. Our program is about loading a model, getting the data into a buffer, and then saving that buffer back out to disk so that it's in a format that can be just loaded by any main program at any time and displayed on the screen directly. We can stream models onto the screen. It will also give us a format for our buffers, which then we can use to make sure that models can be all compacted into one buffer or placed into a single buffer, and then that buffer can be shipped off to be displayed in one single render pass. You do not need to draw every single model individually. All you have to do is draw the buffer. Once you get past the concept of saying, oh, I've got a model, I want to draw it on the screen here, at this location, at this rotation, and at this scale. Once you get past that stage and you start thinking, I just want this lump of data run through a shader to be displayed upon screen, this lump of data can hold an entire world full of thousands and thousands of models. And you will execute that in one pass. Your graphics card will love you forever, because you will no longer be starting and stopping those shader programs and flipping them around and doing this, that and the other, and loading a model, then loading another model. Hey, wait, whoa, let's load another model. Let's put another model over here. Let's put another one over here. All of these models, let's draw them all individually. Like bloomin' numpties. That's the difference between programming 3D and creating the illusion. Well, so when you want to program 3D and create the illusion, you have to first break that illusion within your own mind. So let's talk about that then. I think that went close to the bone a little bit in places. Close to the real truth of how you do it. But I'm not here to teach you how to do it. I'm here to give you insights on the things that you should be looking at to do this. And it is very easy to do once you gain those insights, because you realise that all of those errors that you've been experiencing aren't actually errors, they're just parts of the illusion. Once you can see past the illusion, the errors disappear. The GPU, when it runs the shader program, will only do what you have told it to do. It will do no more, it will do no less. It may add a few variables here and there just for funsies, but they can only be a 0 or a 1. They shouldn't mess up the final product or the final calculation for each pixel on the screen. What you tell the GPU to do should be done. You should have no errors. You might have spectacular illusions erupt out of your code. I know I've had that in the past. Some of them have been really fun. Some of them are kept. They were really good. But you will have no errors. You need to accept that. And then realize that you are dealing with illusions. Now, speaking of that, and this brings us to today's talk. Why Qt and C++? This has been asked of me. If we go over to my YouTube channel. Oh, hello. Oh, we've got a reply. But I see it's wasting of time. Oh, right. Well, if you think it's a waste of time, don't watch it. And you do your best and still underrated. Okay, you think I'm underrated. You think I've got something to say. That's fine. If you don't think that sitting around listening to what I've got to say is a good use of your time, then that's fine as well. Even without video editing would be useful. Yes, I totally agree. Right, Karim. Fraser Sharp is the YouTube channel here. If you go to a place called Amber Skies, which doesn't work on this keyboard because this keyboard's plugged into a different computer. Let me do this first. Come here, you, before we do any talks. I'll do this for you. Here's Amber Skies. There it is. This site is slightly more popular than my site. Okay. Ignore the Patreon and crap. There's no website anymore. I closed that just before Christmas. We'll pop you into here. I think that's what you pop in. Is that what you pop in? I don't bloody know. And yeah, Jamie King's here. He taught me. That's where I started with all of this. He's here. Can't use those links. I don't know what this means. This thing at the top. But these are playlists, and the one that you are looking for, the one that you have suggested, is probably the very first one I ever did, which is Programming 3D Stage 1, 2. Where's 3? Is that it? Stage 3, Stage 4, testing, no. Yep, testing. And then it went on to 3D game programming. So I think what you're asking me about on my channel is something that I did. Is there a date on this? On October the 4th, 2018, which is 3.5 years ago. So you're actually asking me about something that I did 3.5 years ago. So with that in mind, go to YouTube, look up Amber Skies and review the videos which are not streams, and come back to me. I am here to help you. I'm not here to change the format of this web page that I'm using. So this format is not going to change. The video format is available to you. It's just under a different YouTube location. So we do have to reply to you. Okay. Dun, 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 dun. Yeah, I totally agree with what you're saying. Absolutely. Okay. Reply. Awesome. Check Amber Skies on YouTube. Can I keep this open with this search? Because there's this stupid cosplay thing that goes with it. Alright, I think that's the channel. Can we come back to you? No, I couldn't keep it on. So it's check Amber Skies. Control V. Why does Amber Skies not come up? Add to dictionary. Okay. You will find my non-stream videos. Hope this helps. Okay, reply. I've been asked. I think it's only fair that the person wants a more direct input, not a rambling idiot on a stream. That's fine. I don't mind that. In fact, I appreciate it. I will redirect you through there. I'm not trying to make money. I don't want you to subscribe. I do not want anybody to pay for this. I do not need any money. Okay? This is free. 100% free. If it does become a money-making venture, I will stop. I will not do it. This is a games club for you, not me. And yes, I was very forceful when I just said that. That is possibly one of the very edgiest things I've ever just done. Wow. Go me. Go anger. Right, so I think I've answered correctly now the concerns that that person has. Why Qt and C++ was actually... come back, you. And then all we're going to do is it doesn't actually cover that. Damn. It's not from the question, is it? It's from an assumption from the question. It's because he mentions OpenGL mesh loader, an editor with I'm GUI. And it's because that is so precise that I instinctively felt that I needed to defend my choices of what I'm doing currently. And I don't need to defend the choices of what I'm doing currently. What I'm doing currently is waiting for you people to ask me to do something different, which he has asked me to do something different, and I'm going to do it. That's beside the point. Why am I currently using Qt plus C++? Let's just grab a coffee. So, grab your coffee. And settle in. I'm not really supposed to have another cup of coffee today, so I can't have one. So let's put that cup to one side. That's not going to happen. Righty. Luckily, I do have a small can of black burpy bubbly liquid. So if I do start burping halfway through this talk, it's not your fault, it's mine. Now this, I'll give the answer so you don't have to watch the whole talk. Which mouse have I got here? The wrong one? Probably. Damn you. Alright. Give ourselves some space, shall we? I can't talk with my hands when I'm on the internet. So I have to talk with a pen instead. Alright. Settle in. Why Qt and C++? Well, the story goes like this. When I decided to do the Games Club, I needed something to do whilst people either got interested in, wanted to support the Games Club, or whether the Games Club amounted to nothing. To me, it didn't actually matter, and it still doesn't matter, whether the Games Club is successful or not. It's a record of insights into games programming that you will not get anywhere else. You will not be able to take a degree in computer studies and get this information. This information is possibly lost to computer programming or buried within those programmers that have been programming for over 10 years. In fact, now 20 years. 25 years. God, it's 25 years. 23. It's a long time. I've just done the maths. It was 1, 2, lots of time ago. So I thought, well, if I'm going to play around, we need a language. Well, there aren't any languages in computer programming, so that was a bit difficult. I couldn't choose a language because there isn't one. The art of programming has nothing to do with language at all. So, first thing you have to know is that this is not on a brush. Programming is not equal to language. Okay, that's your first step. Once you have gotten rid of that assumption And if you think that you are programming in Java, you're not programming in Java. You are either programming or you are writing in a language called Java. You can't do both. Programming has nothing to do with the language. It is disconnected. A program can be written in any language. A language cannot be written in any program. Get it? They are not tied together. They are separate things in reality. There is no equivalence. So, why Qt and C++? Because it's got nothing to do with programming. So there's your answer. It's interesting because a lot of people have come to me and said, can you teach me C++? And I said, no, I can teach you the program. Some of those people have listened. Some walked away. Me? I don't care. And that's what allows me to do this. I actually really and honestly and truthfully don't care whether you listen or not. And it's why I wasn't offended by what that person said, which was absolutely fine, and he was absolutely, she, do not presume, is absolutely correct in what they were saying. I understand, but I will not change the format of this website. I've done the other formats. I've been there, got the t-shirt, not doing it. I'm not teaching anymore. I'm retiring. I will give you an insight into my life's experience with programming from the viewpoint of what I know how to do best. That viewpoint is... So these streams are from the viewpoint, let's put that in, let's get this solid, from the viewpoint of a systems analyst. By giving you this viewpoint, this is what you will not be taught in a computer programming degree. By giving you this viewpoint, I will give you the information that they aren't going to teach you. But I can't give it as fact, because this isn't part of computer programming. It's not an accepted part of computer programming. It's considered a completely different profession. But it isn't a profession, just like computer programming is not a profession. We don't profess anything. But by giving a viewpoint of a systems analyst, you have now seen me debug programs differently and come up with different answers to that of a programmer. I have come up with the solutions from the understanding of how the systems work, not on the language, the what's Qt? The library being used, but by the systems that are in place. This means that everything that I have said goes for every language out there. Doesn't matter whether it's Qt and C++, that's just what I'm typing to show that these problems exist and solutions to problems are not in the programming domain. They are in the systems and analyst domain. There is a massive distinction we now need to understand between systems analyst and programming. The systems analyst doesn't care about language. The systems analyst doesn't care about the operating system. The systems analyst only cares about the system. The programmer cares about the language, the construct of the systems. The systems analyst doesn't program. The programmer programs. Are we coming to some kind of understanding here about the differences that are involved in the processes mentally about how you start thinking about things? The two realms will think about the same subject from completely different viewpoints. The start of the thoughts starts in totally different places. To me, if I see the colour red, I believe I'm seeing the colour red. But the colourblind person sitting next to me might be seeing the colour green. There are two different viewpoints involved. These two viewpoints are both correct and both valid. But who's right? Are they colourblind or am I? Because I'm seeing red and they're seeing green doesn't mean that they are colourblind. It could mean that I am. And once you understand that principle, you understand why a systems and analyst cannot program. And why you lot out there trying to program are having such a bad time with my viewpoint. To know what is truthful and what is real requires an independent third point. It is the rule of three, which I bring up every time. Without a third viewpoint, you cannot join the two together or equate them. The not equals to remains. And the same is for programming and language. If you are a programmer, what language do you choose to program in? And is it relevant? Does it matter? Well, it depends upon what you choose as your third option, what you need to compare it to. Because to find out whether your program is correct or incorrect, you have to compare it to something. You have to compare it to a reality. I think you are starting to get my drift now. It isn't the programmer who chooses a language to learn. They're not learning how to program through that method. What they are doing is choosing a language that suits the program that they wish to write. Because that programming language has a third option in place that gives them a comparison for what is correct and not correct, whether that be in the form of a debugger for C++, an error system, which most languages have, and most languages will give errors. Does assembler language? Not sure, never checked, didn't care when I did it. But there is that third point. There is that third thing. And each language will deal with that third thing differently. And that is why people will come to me and say, I want to learn programming in C++ or C or Go or Java or whatever. And I will say, no, I can teach you programming. I am not a programmer. I am a systems analyst. I do not know how to program. You get it? And yet you watch me program on stream. You watch me fumble about sometimes and forget a lot because I can't remember anything. But at the end of the day, I return to the system and I go back and I correct any mistakes in the program, and the program then works. I also know when a program works when other people will say that program doesn't work, because it's a different viewpoint. It can cause interesting conflicts of interest because of the massive misunderstandings there are within human society today, especially the programming community, of what programming is. And programming is nothing. It doesn't mean anything. And because it doesn't mean anything, it has become attached to the languages that are used to program. And the first rule of programming not being equal to a language is ignored. And is not taught. The whole concept of programming and language being separate is swept to one side and ignored by the entire community, systems analysts as well. We are not a profession. We have no standards. There is no proof of what I've just said. There is no white paper stating this. There is nothing. And people ignore it. Why Qt and C++? The C++ part is irrelevant, but it just happens to be Qt is written in C++ and gives you access to a library that you can use in a language called C++. even though whilst writing or putting this program together that we've been doing with Vulkan, we have dropped into C quite a number of times. So the real question isn't about C++. The real question is why Qt. So let's break that one in. That's easy. Qt is a one-stop library of functions. A function a piece of code which completes the task. A program is a list of functions called by this. I'm being very generic about this. By the CPU in a given order of logic. And we have to insert Boolean there to be precise, because it's ones and zeros. There's your answer to the whole talk. I told you it wouldn't take long. Why is this not working? Is it this one here? Yes, it is. Okay. Got the right mouse now. So, Qt is a one-stop library of functions. A function is a piece of code which completes a task, and a program is a list of functions called... Oh god, that didn't go right, did it? Function... There we go. Functions called by the CPU in a given order of logic using Boolean logic. At no point did I mention that it's C++, because we can, with Qt, use QML. We can also use Python, and probably a lot of other different languages as well, but that's beside the point. The point is Qt is a one-stop library of functions. Qt has the biggest library of functionality on computers today. The library is so diverse, it will cover every... That's a bit big. Most practical applications for a computer program. There's no E on the end of computer program. Why did I put an E on the end of it? Do you get it? Do you see what this is about? If we are going to talk about a subject like games game programming, we have to have a foundation which does not restrict us, because game programming is about breaking the boundaries. It's harder to be a game programmer than it is an application programmer. It's harder to be a game programmer than it is to be a hacker. It is the most difficult thing you can do on a computer, is to program a game. Because you then have to look at the definition of a game. That does go outside of the realm of this talk, but at the same time, you have to know why. A game has to be unique. Full stop. How many different spreadsheets are there out there, and are they all unique? There are lots of spreadsheet applications out there, and none of them are unique. That's an application. How many different games are out there, and how many of them are unique? There are lots of different games out there, and at least 50 to 75% of them are unique. That is the definition of a game in programming terms. If you are the inventor of a new application that is therefore by definition unique because it's the first of its kind, have you programmed a game? Yes, you have. It's going to be a damn good game trying to use it. Or working out the application of. It's called an application because it can be applied. The game is what can it be applied to. So if you generate the first ever application of a unique nature, you have written a game. Because nobody knows what the hell to do with it. That's by definition. Once that application has been applied and been evaluated as useful, that application will then be duplicated. It no longer becomes an application. Sorry, it no longer becomes a game, it becomes an application because it has usefulness. A game does not. A game is not useful. Once that distinction is made, the whole rules of programming change. You then have to stay within the boundaries that have been created for that application. Otherwise, it can't be applied. In a game, those boundaries do not exist. You are free to do what you want. At that point, you have to realize how very, very, very difficult it is to program a game. It has to be unique. Yeah, you can copy the styles of other games. First-person shooter genre. But those are genres. They are not an application. They are types. They are categories. They are fictional labels that we place upon games to put them into collections so that we can identify what the hell they are. And that's the human way of doing things. All of this I do find an interesting subject, and it does answer why Qt and C++. The answer is simple. If I am going to be looking at games, I do not want to be tied to a language. That's the first thing. Why do I play around with Qt whilst on stream? To give me something to do. It'd be a pretty boring stream if I never did any well, I don't think I actually do any programming, but if I never did anything. I'm trying to get people interested in game programming. I'm trying to get people to open up and talk about it, and how difficult they are finding it, and how what's stopping them? What is stopping you from making the next big game? And those big games have existed. There's been some very big, unique games. We all know what we're talking about here, don't we? An MMO. You know the one. I don't need to even name it. Anybody watching this will know what that program is, and they will know about the history of that program and who made that program. They will know everything about it. It is famous. And in the future, people looking back in on this will know about it without me even saying what it is. I think Qt is interesting. We have experienced some problems with it, and we have experienced some problems with Vulkan during all of this. I do find this interesting, especially in the realms of what we've been talking about. Mainly on the side of security, that came up. That I found interesting. And also on developing systems to be implemented within games that are useful, which you have to do. Oh, I accidentally wrote it in here. Okay. That's fine by me. That's okay. Does this work? Yes, it does. That works perfectly. We know it works. We've seen it. We know what's going on. Run it again. Yeah, you see, it won't even show it now. The clip plane has sorted it out. Okay. Yeah, everything's working now that I can see. Do a rebuild, see if we can get that clip plane cleaned off the GPU. My FPS is not moving. Good, it's working. It should come on screen now. There it is. There you go. There's proof that it's working. We just had to cause a real number error in the calculations on the GPU to see the model being shown as we are inside it, and it is inside of the clip plane, which means we shouldn't be able to see it. But by causing the error in the calculations, we can visualize or see that it is actually there. There we go. That's perfect. I think we've done well today. I could be totally wrong about my conclusions as usual, but I doubt I am. Let's just get rid of you, shall we? And we are doing pass 1, isn't it, on model loading. Model loaded and displayed. It's pass 1. Will require MVP matrices for the model to be visualized properly on screen. But everything's working. That's the answer. It's in the commit. It is under convert blender to midnight. Oh, I just clicked it twice. What's going to happen? Yeah, I thought so. Alright, we only seem to got one out of it. Push. So to find this code, you may hunt around on the internet. You should be able to go to Fraserblade Sharp here on GitHub. You will see that we are using Rana as the project. And if you go, gdev had recent pushes less than a minute ago. Compare pull request. Really? Main dev view code source graphics. This is with the corrected shaders as well. I've put those in here. Just remember, if you do download this and you try and run it on Windows, you probably won't be able to do so successfully without changing the pathing. The pathing on Windows is different to Linux, as we found out. Graphics. We've got the model loader. We've got the renderer. Make sure that model loader got corrected. Yeah, index less than. Okay. And the rendering is up to date. Yeah, that's all out. We still have quite a lot of QD bugs in here. It is past 1. So yeah, we do still have QD bugs in here, giving out information which can be taken out. And the notes are looking okay. They have been added, haven't they? About the model. There's a shader. There it is. So the notes about the model, they're actually released now. We are in pass 1, not pass 2, so that's fine. Good. The code is garbage, but it's a start. Does anybody need me to cover anything else today? We're on Saturday, aren't we? Are we doing a talk tomorrow? Or are we carrying on coding? I mean, I'm quite happy to do the MVP. I did want to get it all finished by the end of this week. So I could go into overtime and work tomorrow as well on it. And just throw in the MVP. I'm not sure. Was I going to do AI tomorrow? Because I wanted this to end this week. So it was supposed to stop today, and we've run out of time. We're on now 4:24. If I continue, I will literally be crying myself to sleep in pain tonight. So I would prefer not to, for physical reasons. Do we do another week on this subject? Because if we don't, we're never going to complete it. We've actually completed it already. All I have to do is put the save function in. The visualization of this is immaterial to the actual purpose of the converter. We have what we want. It's in a buffer. All we have to do is save it. All we have to do is type in a save routine to disk at, well, wherever we want. In main will do. So save buffer to disk to whatever. Binary. Ready to be used in any. This is the midnight. Midnight. Library game. I'm not going to call it a game library. I'll call it a midnight library game. It isn't a game library. It's just a collection of functions we're accidentally making along the way. To save the file is the opposite of loading a file. We have a model loader. What file description shall we give it? So file description, we'll have one of those, q string file extension. It's going to be dot midnight model data mmd. I don't know. I'm just making this up as I go along, peeps. Midnight model data, which is pre-formatted. So I've got that. Where's it going? Well, where did we start? Where did we load it from? the same directory as we are in already. We just need that part there, don't we? We don't want the .obj. We don't store that either. But it doesn't really matter. If we've not stored it, it doesn't matter. This is an example code. I don't like doing it this way. We should take this string, we should remove the obj off it, and then we can store the string and use that and put it to a .mmd and output that file. So what we're going to do is something slightly different to make things easier on ourselves and less code, basically. We just need to open a file, don't we? We can do that quite easily, I would have thought. What's a good way of opening a file? I don't want to use asmp. If we use a q-byte array, do we actually have to create one? Or can we use a vector direct? Q-byte array. How can we construct one? Q size -1. I wonder how that works out. I don't see a Q list being used here. No, I see chars. 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 Other q-byte arrays. Const char star. That's a string, a standard string. We can use that. We can't push back a queue list. Reserve resize. Set raw data is from const char star data. That's a standard string of that size. We can get a queue size type easily. A const char star data we can get, so we can do it that way. It looks like we're just going to set the raw data. I notice we don't have a from. Okay. It's looking like we're using setting raw data. I don't know what those two are. Not without looking them up. Alright. Set raw data it is. Just pop you off for a minute. Does this need to be a memory location? Yes, it should be. Star output equals a new q-byte array. I'm guessing we should really pop this in as an include as well. We'll hash include that. We may as well hash include Q file to go with it. Okay. So we've got those two available to us now. Should they be the other way around? Yes, they should. Okay, that's better. I don't want those two being messed up. It's a new q-byte array. And it's going to be const char star a, which is coming from our model. So let's just pop you in. I don't think I can do it like this. I'm just writing out the full line first. So it's our model, VBO storage, raw data. No. Is it just data then? I'll go with data for a second. Can't do anything with that data for a sec. Comma. It wanted a queue size thingamajiggy, didn't it? So it's going to need our model. VBO storage. Size. And that should give us something. Queue size type, that's what it was asking for. That's fine. It's going to need a size. It's not going to like that at all. Can we have q-byte array with a size involved? Char ch. Const char. Oh, we can put it inside. Oh, we don't need to put it outside. Okay. That's nice. So we don't need to set it as raw data. We can just pull that back. to there. No matching constructor. So this data isn't giving us char stars. We're in QList. We're not, we're in game model. Game model gives us a QList, does it? It should do. Yes, it does. QList, how do I get my char star value? Please. What does data give us then? QList it's giving us a pointer. That's why. It could be data const though. Char star. Is that allowed? Is that what it's complaining about? AKA float star to const char star. Ah! Yeah. There's that. Ah. We'll need a dot to char star, I'm guessing. Can't we just get raw data out of this? Can't we just get binary? That's what I'm looking for, really. I just don't want to do a for next loop. That's what I'm trying to not do. If you're wondering why I'm doing it this way. QData stream operator. We can stream things in. Provide similar arrays. QList, yeah. So how do we go between the two? We need to change our floats into characters, I guess. Do we? We might be better going to string. Will a queue by array hold strings? Yes, it will. We've been there before, haven't we? We've been using this in our strings. What were we doing? What were we doing? Let's just have a look at what we were doing previously. We were just reading a text file. Well, now we could just suppose, well, If it's held as a text file, we can still... It's like juggling cats. I don't like the EOF character. Alright. I want to open a binary file and just smash all our data out there. Can I do that? Let's find out. So what we'll be looking at is reading files directly, using streams to read files. We are using what? Okay. Text stream. Okay. Q data streams. Yeah, these are Q byte arrays anyway. This is all about reading files. What about writing files? Oh, it's here. Basically, we're just getting these two lines here. I mean, that's really all there is to it. Except it's not read-only. It's write-only. Instead of text, I would like binary. Can we have binary? Je ne comprends pas. It isn't in text, it's going to be... that. Plus file extension. Why won't it do this? Oh, it's because we've got errors above. Okay. My bad. Let's sort this out properly. It's a char star. It's not coming up, why not? Write only existing, only newly or not, read only, write append text. Truncated, unbuffered. I'll just stick text in for a minute. Just do that, just to shut it up. All we need to do there is that. That shuts the rest of it up. Everything's correct now. Expected, an expression. Thank you. File. Extension. Dot. 2. std string. Okay. No matching garbage. What were you expecting? Why is there no matching garbage? I was expecting something different. So what should this be a Q file of? Where's your constructor? That's QString. I didn't ask for QString, did I? Whoops. Q file, that's better. Oh. Name. It wants a Q string, and I'm giving it a standard string, so that I was correct. There you go. Oops. I don't want it to write in text. What formats can we have? I could just output it like that in a QText stream, can't I? Then I don't have to convert. That's an interesting idea. That'll read lines. I have to be careful with that because that will have \n on the end. It's this \n here that I'm worried about. QIO device. What types have you got? You can see that I'm not looking at this as a program, I'm looking at this as a system. I'm more concerned about a \n than I am about what I'm writing here. Where are you setting your type? So you can get chars off, so you can put... That's binary, is it? No, it's not. It's text char star. Okay. I don't need a \n. That's very close to it, but you're also breaking out of the rules of C++ a little bit there into C. Reading and peeking and poking. My God, that brings back. This is what I was thinking here with the Q byte array. So we can read straight into a Q. The whole point of this is that I can write that line there. This read business here. We can just read a model straight into a buffer, a Q byte array. Hopefully converting that Q byte array straight into your model buffer. That's the idea, but I want it in the correct format when it's written out. This is all about reading, you see. Where's our writing? It comes under W, it'll be at the end. Set current write channel, okay. Oh, returns the mode. Ah, here we go. Unbuffered. Any buffer in the device is bypassed. Okay. When reading... when writing, the end-of-line terminators are translated to the local encoding. For example, \rn for... Oh, sugar. That's going to be messy. We could bypass the buffering. The device is open for writing. Note that for file system subclass e.g. Q file, this mode implies truncate unless combined with read only, append only, or new only. Truncate. If possible, the device is truncated before it is opened. All earlier contents of the device are lost. That's fine, I don't mind that. New only, that's an interesting one. When reading the... I don't want this text business. Just take the text off. Stop telling it to use text. Fair enough. So once you've done that, the file is open. It's called file. what do we want? Our model data. We can't do that direct, why not? Invalid operands to binary expression. Yes, we have binary. Candidate function template not viable. No known conversion from Q file to Q data stream and for first argument. It doesn't know how to convert float to binary. So we have to convert it to something. Does that star mean anything? Yeah, that's the pointer, so we need to deref. We want the contents, we don't want that. We have to convert it to something. Why has it got two when they're both the same now? They haven't updated this, have they? Interestingly. It's in the format of QList. What can we put? What can we do with QList outputs? We can have. Sorry, what were we looking for first of all? Get rid of that. Let's get. I want my error message. What we're looking for? We're looking Q file and QList float. So we're looking to get to a Q data stream. What kind of data can we get to? I don't think we can. No, we can go from QList to QList. Ah, Q data stream and we have an operator here. So what's it talking about? It says it can't convert. No non-conversion from Q file to Q data stream. Alright, that might be true. It means I'm using qfile wrong. It can convert. It's not file. Why am I so useless at this? We've just seen it writing out too. Where's the right thingy? Where's read and write gone? Okay. Oh, I hate this part of programming. If file.open. Ah, we need to create a do-free. Okay. So that's an error check. We need also a thingy, a queue data stream. Okay. Output. For the file, like that. That comes out of here. That was just an error check. And that becomes output. Paste. Done. That should output whatever's in storage to the file. We don't need an if statement. We just want the file to be open, please. We don't want any stupid stuff going on here. We don't need the scope. That's the code. I'm not in, those are just ideas. That's to make it easier for me to remember what to do next. Once we've done that, we should really close it, shouldn't we? Flush buffers. And that would be file dot close. Do we need to close output to flush the buffer? Because we haven't told it to ignore buffers. Do you need to be closed? No, you don't. Okay. That will happen in the directory of what? In the directory of base floor tile. Where is base floor tile? Good point. Damn, developer tools are fun. Is it in here? Yeah, it is. So we're expecting to see as a result, a .mmd file appear in here. There is no such thing as a .mmd file, which is good. I'll just do a quick compilation, make sure we haven't really cocked up. Try that again. Alright. Okay, we're getting our revolving internal view. We have an MMD file. Yes, that is binary, not text. Fantastic. Check. So we can now open file. Binary. There we go. There's a lot of question marks in here, which is fine. It's not that that's we need, it's the... Oh, right, because it's in floating point. We won't be able to read it direct. I have no idea whether that binary file will work or not. If I read that file back in, what do we get? But it looks as though it's the correct data. What file size are we on? Remember, the magic number was 1030 something for the size of the data. How do I find the size of this data? It says 2 kilobytes. ls list. Okay. Here we go. 2020. So something's been added. I'm guessing that's to do with the file size. No, that's a year. 2nd of April 2020 maybe? No, that's the size. That looks weird, doesn't it? So our OBJ file was 1028. That's compressed. Uncompressed, it comes out at 2020. The Blender file comes out at 786860. Holy crap, Blender, what are you doing? But we've created a new file type called MMD. I should be able to copy that now and load it into a different filing system. Yeah. Now we can't visualize our model at this current time. So that's it. That's the whole thing done. We have loaded and saved a model from a .obj to something that we've invented called Midnight Model Data, MMD. Doesn't exist. It's not a format that is regulated. It's just something we've made up on the spur of the moment. It's not compressed. It's not efficient. Nothing like that. It's just me dumping out data into a file. It's a dump, a data dump. We've closed the file. Everything's worked. We've got a file. We've opened it. It is binary and it does contain data. Good. Complete. Done. I'll pop that up for you as well. No reason not to. Wasn't hard. Data dumped to a bin. Sorry, model data. Saved to file. Dumped data to binary. Ready for main application and main game. I think it is anyway. There's no reason to say that hasn't worked. It does need testing. We are in pass 1. There you go, we've done it. Tough. Wasn't hard. There's the code. Do with it what you will. Prove me wrong. Like I said, I'm not a programmer. That's the system. I've just written you the system. Go program it. That's all that's needed. Okay. And you'll find that at Fraserblade Sharp /Rana under GFX Dev. You will not find it in main. Model loading and displayed. One minute ago. Yep, code's there for you. Good, done. Is Convert Blender to Midnight complete then? We have no visualization and we have no test for the resulting MMD file that we've just invented. Is it correct? The system's correct. What about the files? Yeah, I know, Poppy. She's looking at me. I get so involved with what I'm doing. So we did the talk. We did a bit more programming. We're good people. We've done very good today. So let's just pop that in. We've got no ticks here. But we now have the last part complete. Let's see, did I need to do this anywhere else? Oh god, this is all over the place. One sec. This is not good. Let's get this extra keyboard out of the way with that computer switched off. Ah, lovely. That mouse doesn't work now. It's on a different computer. Bring back this computer's keyboard. Here we go. We're back in business. We have completed the challenge. I did want it completed by today, so we just have done it. So, saved. Data to binary. File. Ready for the game. To load. That was the objective of the utility. That's completed. If you're thinking in the back of your mind, hold on a minute, you don't know that that's completed. Sorry, but I do. I trust myself. You see me double check myself all the time. But when it comes to a system, I trust myself. The only thing we haven't got is this middle bit. People might not know how to do that. Well, that'll be done in the game system anyway. I can program it into a game system which would probably be more useful to people. This isn't an editor that I've made. This is a converter. A converter from currently, well, actually anything that's async. A converter from Blender export files to a binary file for loading into a game. That's what it is. We've created it, we've done it, we've finished it. Pass 1. It's still missing features like being able to view the model because the camera's stuck inside the middle of it. But that's about it, really. Yeah, happy with that. Good project. Done. There's our model. Yeah, everything's written up properly. The ticks are in the right places. What about this here? Does not display test data. Yeah, that's all been corrected. Yeah. Alright. Whether you do that bit there or not is your choice. We're done. So, tomorrow, talk on AI maybe? Shall we have a chat about AI? What we got on the talkie boards? What we got on research? We have 3D graphics mouse picking. We've got AI, monetization of the game. That was an easy talk. We have viewer feedback has been added. So we do have OpenGL Mesh Loader and Editor with I'm GUI. That's been added to the board. All ideas are welcome. I think we're done. Yeah, Poppy says we're done. All right, Poppy, we're done. Okay, don't look at me like that. She's very accusing. Take care, peeps. Let me get out of here before I go mentally disturbed. Yeah, there's this, isn't there? Discord as well. If you want to go on Discord with us or contact me outside of streams. There is a Discord server. Pop in chat. Just stick a request in. I'll give you a link. I don't see any private messages coming through about this either, do I? None. Whispers. What's this? Polyglot? I've got some code that I've received. You've got a GLFW init here that's giving you a display error. Looking at what I'm just looking at here quickly, if you are watching currently, that is a display error. Are you just checking for an error? I don't know how long ago this is timed. Is this dated at all? Oh, this is from February. I think we might have already discussed it then. Not pitch black. Yeah, that's right. Yeah, OpenGL. Right, got you, Golang. Sorry. Yeah, we've done that. Fine. Everything's done. I'm happy. We'll let it go. Take care, peeps. It's Saturday. Have a good evening. How do I get out of this? That one? Yeah. Have a good evening and chill out. Chill out and have some fun. I hope today's been good and people have got the information or at least gained something from today. And maybe one of you lot, or even me, I might do something spectacularly genius and shake the world. Take care, peeps, and have fun.